Rab explains it all. Math, chem, physics never fall. Subscribe and learn. Ace every test, so Rab explains it best.
Hi everyone, I hope you're doing well. Welcome to this video and welcome to my channel. In this video we are gonna learn how to prove similarity into triangles, and we are gonna get familiar with three different postulates and how to use them. Okay, without wasting any more time, let's jump into today's lesson. The first method that we have for proving similarity in two triangles is AA, or which is the abbreviation of angle. What does this postulate say? It says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So the only thing that we have to do is proving that two angles from one triangle E are congruent to two angles of another triangle. Assume that we have two triangles. One of them is ABC, the other one is DEF. If we know that angle A from the first triangle is equal or congruent to angle D, which I have it here, and angle B from the first triangle is congruent to angle E from the second triangle, then I can realize that triangle ABC is similar to triangle DEF based on AA postulate. Okay, let's solve an example about it. Here we have two triangles and we want to prove that the triangle ABC is similar to triangle DEF. As you can see, I have angles in triangles, so I can realize that I need to use first postulate because it is about angles. So I know that this angle is 30, this one is 75. I want to find this angle of this triangle. I'm going to call it X. And I know that the addition of internal angles of a triangle is going to be equal to 180 degrees. So X plus 30 plus 75 is going to be 180. And I can realize if I solve it that X is 75 degrees. So this angle C, 75 degrees. Now I can realize that angle B from the first triangle is congruent to angle F from the second triangle, and angle C from the first triangle ABC is congruent to angle E. So based on AA method, I can realize that triangle ABC is similar to triangle DEF. Really easy. The second method that we have for proving similarity into triangle is something which we call it side angle side, or the abbreviation of that is going to be SAS. What does it say, SAS postulate? It says for proving similarity into triangles, the only thing that we need to do is proving that the ratio of two pairs of corresponding sides are equal, and the angles between those sides, not any angle, the angle which is between those sides are congruent. Assume that we have two triangles, again ABC and DEF. We want to prove that these two triangles are similar based on SAS postulate. If I know that the ratio of AB, and what is the corresponding side of AB in the second triangle? DF. The ratio of AB and the DF is equal to the ratio of AC and its corresponding side, which is DE. And the angle between those sides, look, I'm talking about these sides. So the angle between these sides is going to be A, and the angle between these sides is going to be D. So angle A is congruent to angle D. Now I can realize that based on SAS method, the triangle of ABC is similar to triangle of DEF. So what I need to do in this type of question, I need to prove that the ratio of two corresponding sides are in proportion and the angle between those sides are congruent. Okay, let's solve an example about it. Here I have an example. As you can see, I have the length of sides and I have angles. So I can realize that I need to use second method, which is SAS. Okay, let's start. Easily I can realize that angle A is congruent to angle D. The only thing that I need to do. So angle A is congruent to angle D from the second triangle. Okay, let's start with AB. I know that the corresponding side of side of AB in the second triangle is DF. So I'm gonna write it here. Why the corresponding side of AB in second triangle is DF? Pay attention to this 30, right? I can find this side in the left side of this angle. And as you can see, DF is located on the left side of the angle. So let's calculate its value. I can write 4 over 2. It's gonna be 2. And I know that the corresponding side of AC, look here, I started from the first triangle and here I'm gonna start from the first triangle again. You must consider the order. Divided by DE. Why are they corresponding sides? Because as you can see, AC is located on the right side of 30 degrees and DE is located on the right side of 30 degrees. Is gonna be 4 over 2. It's gonna be 2. So based on these, I can realize that AB over DF is equal to AC over DE. It means these ratios are in proportion. Okay, I'm going to continue here. I know that the angle between those corresponding sides are congruent and the corresponding sides are in proportion. What can I realize based on the second postulate, which is SAS? The first triangle ABC is similar to triangle DEF. Really easy. The third and last postulate that we need to talk about is SSS, which is the abbreviation of side, side, side. What does it say? It says if the ratios of all three pairs of corresponding sides of two triangles are equal, then the triangles are similar. So in this postulate, we are not going to talk about angles. If we have only angles, we are going to use the first method. If we have angle and sides, we are going to use second method. And if we have only the length of sides, we are going to use the third postulate. Look, I have A, B, C, and D, E, F. Both of them are triangles. And if I prove that the ratio of corresponding sides are equal to each other, for example, AB divided by DF is equal to AC over DE and BC over EF, they are equal and they are in proportion, then I can realize based on SSS method, the triangle ABC is similar to triangle DE. Okay, let's solve an example about it. We want to prove that triangle ABC is similar to triangle DEF. And it's gonna be easy. Look, I have the length of sides and I do not have any information about the angle. So I can realize that I need to use third method, last method, which is SSS. So let's find the ratio of AB from the first triangle over the corresponding side from the second triangle, which is DE. It's gonna be 6 over 3 or 2. And let's find the ratio of AE and DF from the second triangle, again, it's going to be 6 over 3. It's going to be 2. And finally, BC from the first and EF from the second, it's going to be 3 over 1.5. As far as I know, it's equal to 2. So I can realize that these ratios are equal to each other. So ratio of all the corresponding sides are in proportion AE over DF and BC over EF. So I can realize that based on the method, which we call it SSS or side, the triangle ABC is similar to triangle DEF. Really easy. Okay, let's solve more examples with each other. I have one triangle here. What does the question say? In each case, prove that the given triangles are similar. In this case, we want to prove that ABC and ADE are similar with each other. As you can see, A is common in both of the triangles, in the larger one, which is ABC, and in the smaller one, which is ADE. So I can write angle A is congruent to angle A. It's obvious it is common between those two. Look, here we have two parallel lines. And by the way, this is really famous and common question that you can encounter in the exam. So I can write that BC, this segment, is parallel with DE. Okay? And AB is transversal line. You can see it here. AB is transversal line. So I can realize the angle B and the angle D are equal to each other. What is the reason that they are equal to each other? We have two parallel lines and one transversal line. It means that they are going to be corresponding angle. Why? Because both of them are located at the top of the parallel line and in the right side of the transversal line. So I'm going to write AB transversal line, TL. So angle D is congruent to angle B. And again, with the same scenario, we can realize that I'm going to write it here. Again, BC is parallel to DE, and this time AC is transversal line. So these are going to be corresponding angles. So angle E is congruent to angle C. So I have proved that all the angles are congruent. Even two of them would be enough, but I have proved that all of them are equal to each other. As long as two angles from two triangles are congruent, we can easily realize that the third angles are going to be congruent because the addition of internal angles of triangle is 180 anyway. Based on AA method, angle, we have proved that the triangle ABC is similar to triangle ADE. Really easy. Here we have another question and we want to prove that ABC is similar to ADE, and I have some of the sides but not all of them. So I can realize that I need to use second method, two sides and the angle between them. I'm gonna use this method. Okay, it's gonna give you a view for solving these examples. Okay, I'm gonna start with finding the ratio of corresponding sides. This is the first one. A B from the smaller triangle over AB from the larger triangle is gonna be 5. What is the length of AB? As you can see, this one plus this one, so it's gonna be 15 or 1 over 3. Again, I'm gonna start from the smaller triangle. AE over AC is gonna be 8 over 24, exactly like the method that I told you, 1 over 3. So these ratios are equal to each other. So AD over AB is gonna be equal to AE over AC. I have proved this. The only thing that I need to do is proving that the angle between those corresponding sides are congruent. And as you can see, A is common between those two. So it's going to be equal. So angle A is congruent to angle A, which is clear. It's common between them. So I can realize that based on the magical SAS method or postulate, the triangle ABC is similar to triangle ADE. Really easy. Here, we know that ABCD is parallelogram, and we want to prove that AOB, which is this triangle, is similar to DOC. Do I have the value of size? No, I do not have the value of size. So which method do I need to use? A. It is really easy, right? So I'm going to call it O1. So I'm going to call it O1, and this one is O2. Do you agree that O1 and O2 are vertical angles? Yes, of course, they are in front of each other when two lines are intersecting each other. So I can realize that vertical angles, so angle O1 is congruent to angle O2. Really easy. And because we have a parallelogram, we know that these two sides are what? Parallel. So I'm going to write AB is parallel to DC. And which one is the transversal line? I'm going to consider DB is a transversal segment. So DB is transversal line. Let's talk about it. I'm going to call it D1, angle D1, and this one angle B1. Okay? Because these two lines are parallel, and this line, this segment DB is transversal line, we can realize that D1 and B1 are equal to each other. What is the reason of that? The first method is both of them are acute. So acute angles are equal to each other when we have two parallel lines and one transversal line. The second method is because they are alternate interior angles. It forms a Z. So I can realize that, angle B1 is congruent to angle, D1. So I have proved that two angles of these triangles are congruent with each other. And I can do the same for A1 and C1, but it is not needed. Again, you can do it based on a transversal line and parallel lines. So I can realize that triangle AOB with which method? AA is similar to triangle DOC. Really easy. Here you can find more examples, and I strongly suggest you to solve them at home. If you have any question or if you wanted to share your answer, please feel free and write it in the comment box. I will try to answer them as soon as it was possible for me. Thank you for watching this video.